Hi, now we are seeing about how to interface ADC in 8051 microcontroller. Whenever they are using analog sensor, we need ADC. 8051 doesn't have internal ADC, so we are interface on externally. First of all, we want to write the code for ADC on Keil compiler. This is a program for ADC. Here, hash include register x51.h is the header file of 8051 microcontroller. Then we want to give the prototype of our function. These are all the prototype of our function. ADC containing 8 data pin. By using address, we want to connect the data pins into microcontroller. By using SFR register, we want to connect the data pins into microcontroller. Depends on S bit, we want to connect 8051 pins into ADC. Here RS, RW enable these 3 pins called as a control pin of LCD. Here SOC, EC, 0E is called as a control pin of ADC. These are all the global declaration of the variables. First of all, we want to discuss about ADC program. Here OE equal to 0, enabling value we can make it as 0. SOC is the start of conversion, then we can make it as 0. Between this process we want to give some delay. Here we are waiting conversion. Whenever the ADC conversion is done, which is indicating by this condition, then we are enabling ADC values by using OE equal to 1. Then we are getting that ADC value into one temporary variable. Here we are multiplying ADC value with 1.96 due to some approximation output. After that, we are converting will be started for LCD. This is the conversion for LCD. Then we can pass these values into LCD by using LCD data function. Here 0x30 is the 0 of character value in hexa format. After that, we are using LCD string function. By using this statement, we can checking the whether our string is the termination will completed or not. Then we can pass the data into LCD data function, which is used to displaying on LCD itself. LCD containing 2 modes. One is the command mode, second one is the data mode. By using the command mode, we can select the lines of data printing. When RS value equal to 0, which act as a LCD command mode. When RS value equal to 1, which is act as a data mode. If RW value equal to 0, which is indicating the writing on LCD. Whenever the input will come, we can store that value into port 1. Then we want to pass that value data onto LCD by using enabling pin high to low. Between this high to low, we are giving some delay using delay function. Why we are using delay function here? To avoiding the overlap of data. Here LCD initialization function is there. If you pass 0x38 into LCD command function, which is enabling the both line of LCD. If you give 0x01 to LCD command function, which is clearing the data on LCD. If you give 0x0c to LCD command function, which is enabling the LCD on condition. After that, we are giving some delay function. Delay can be generated by many ways. Here I am generated by using simple for loop. Come to main function. we can call the LCD initialization function. If you pass 0x80 into LCD command function, which is enabling the first line of LCD. After that, we are giving the our string into first line. Here our string is called as temperature. While one is the infinite loop, then we are selecting the some specific space for ADC data print on LCD. If we call this function into main function, ADC value printed on LCD. This is the program for ADC. Save this program and give the crystal frequency for 805 microcontroller. It's 11.0592. Then enabling the hex file generation. Then add the program for source group. Then compile the program by using build target option. If any error will be present in this program, which is shown on command prompt, here there is no errors and warnings. So our program successfully compiled. After that, we want to do simulation for ADC. Simulation software name is Proteus 8. This is the design for ADC. Here we are using 0808 ADC IC, which is containing 8 channel. Here we are using only one sensor, which is connected to the channel number 1. By using this 3 pin, add A, add B, add C, we can select the channel. If you make it as these 3 channel, make it as 0, we can choose the sensor to channel 0. Then we want to give the clock for ADC. Then ALE connected to the startup operation. Depends on the program. We can give the connection on simulation itself. This is the temperature sensor. Number is LM35. If you use port 0 on 805 microcontroller, we want to give the pull-up resistor. Port 0 doesn't have internal pull-up resistors. Depends on program, we can give the connections on LCD to microcontroller. Then we want to give the crystal frequency of 8051. Then choose the X file path and play it. If our code will be correct, execution will be done. Here, if you increase the temperature value by using sensor, which is varying, depends on increasing the input value. This input value shown on LCD itself. So this ADC simulation successfully executed. Likewise, we are designing the hardware. For more enquiries, just contact SPIRO Solution Private Limited, website spiroprojects.in.